Algebra 2, this is Chapter 4, Section 6, and this is going to be called Cramer's Rule. There's going to be 4 videos in this section. This will be the first video of 4. And this one's just the basics of, okay, so where did Cramer's Rule come from? Believe it or not, some bored person sat around for hours and hours and hours, days and days and days, and finally came up with this. So let me show you what we've got here. If we've got 2 equations with 2 unknowns, and you know that the A's and the B, the C, the D, the E, and F are numbers, X and Y stay X and Y. We want to solve this with elimination. We could multiply the top row by B and the bottom row, the top row by D, the bottom row by B, and that would eliminate my Y's, and then I can get my X's by themselves. So let me go ahead and do that. So I'm going to multiply this top row by D, this bottom row by B. So that becomes A dx plus B dy equals ED. And then that's going to be negative BCX minus B dy is equal to minus BF. When I bring that straight down, that's going to be A dx minus BCX. These two cancel out, and that's going to be ED minus BF. I want to get X by itself, and so we are going to distribute, use the distributive property. So X is going to be equal to AD minus BC, and that's going to be equal to this ED minus BF. And then when you get X by itself, you're going to divide both sides by the stuff in parentheses. So X is going to be equal to the ED minus BF all over AD minus BC. Can you kind of see that this looks like our 2 by 2 determinant, the AD minus BC? Well, that's exactly what we're using. We're using our determinants here. Let me go find and solve for X, or for Y. I'm going to do the same thing. I'm going to multiply the top by C, multiply the bottom one by A, because we got the A and the C right here. That way they multiply out. So that's going to be an ACX plus a BCY is equal to CE. And then this is going to be a negative ACX minus a DY is equal to negative AF. The ACX's are going to cancel, so this is going to leave a BCY minus an ABY equal to CE minus AF. Distribute property to take the Y out, so Y is going to come out. This will be a BC left here and an AB left there is equal to CE minus AF. And then divide both sides by this product down here. So Y is going to be equal to CE minus AF over BC minus AB, which is exactly what this is up here. It's just written a little different. So I'm going to rewrite this. I'm going to take a negative 1 out on the bottom. And you'd be like, why are you doing that, Miss Sal? Well, because I want the bottoms to be the same so you can see that where the formula is coming from. So if I take a negative 1 out on the bottom, that actually makes that an AB minus the BC that we had up above. And that makes that the CE minus AF. But you can't just take the minus outside, so I'm going to multiply the minus on the top. So my final answer is going to be the AF minus the CE over the AB minus the BC. So that's going to be equal to Y down here. And this is going to be equal to X up here. And notice that we've got the AB minus BC, the AD. I have something wrong somewhere. My dyslexia kicked in, didn't it? Found it. I think that's supposed to be a D right there. Yep, that should be a D. So that one's a D, which makes that one a D, which makes that one a D. which makes that one there the D, which makes that one there the D, which makes that one there the D. And now it agrees with the one up above. Okay, so we've got AF minus CD, and then we've got EF minus BF, and then the same denominator. So let's, there's the actual formula for you, written as determinants. So the EF is your solutions. Your AC here, it's coming off the x's. The BD is coming off the y's. And if you want to solve for x, you're going to put the solution where the x's go and keep the y's. And then you just use all four of these as it is. If you want to solve for y, you put the solutions on the top where the y's go, keep your x's, and again use the regular coefficients down at the bottom. And notice A, B, C, D cannot be equal to 0 because you can't divide by 0. So it's just a little side note. So the A, D, B, C again comes from this A, D, C, B when you multiply your diagonals. If you were to write this as a matrix, right, we have our AD and our CB, AD minus CB. So take a moment, write down the formula so you have the formula for how to solve this, and we'll move in the next example where I actually do a problem.